Okay, hi guys. Now, okay, let me put this down here for now. Okay, so what we have, this is the video for review question number 4. So in this one, we have a hash table starting with size 2 and a load factor of 0.76. And I set up the hash table here, 0 and 1. That's the two indexes in the initial hash table. Now note that 0.76 is a little more than 3/4. So if it's more than 3/4 full, we're going to double the size of the hash table. So I'm going to put in, okay, so this is a size 2. So 2 mod 2 is 2 in this hash table, and 3 mod 2, and now it is full. So we're going to rehash this. So we're going to create a new hash table of size 4, double the size. I'm going to get lazy about putting in that initial arrow. You guys all know it's there. So we'll start mod 4. The 2 goes in here, and the 3, mod 4 is 3, goes in there. And now it's only half full, so I don't have to do anything until I put in first the 11. Now the 11 also goes in the 3. So now there's 3 items. So it's 3/4 full, but it's less than 0.76. And then we put in 12, which goes into position 0, since there's 0 remainder from 12. And now it's 2 full. So what we do is we rehash, we create a new table. So let's, of size 8. So we have 0, 0. 1, 2, 3, 4, 5, 6. Remember, a size 8 goes from 0 to 7. And now, size 8, the 12 is going to end up at position 4. Since 12 is 8 plus 4, the 2 still is in position 2. Okay. So we've got to put these guys. So this is the rehashing process. The 3 goes in position 3, and the 11 also goes into position 11. So it doesn't always all end up with 1s, right? And so that tends to 2, 3, 11, 12. Now we're going to put in 21, which is 8, 16 plus 5, so that goes in here. 21. 23 is 16 plus 7, goes there. 6 goes into 6. And how many do I have now? 1, 2, 3, 4, 5, 6, 7 out of 8. That's more than 3/4, right? When it was 6 out of 8, it was below 3/4, but now it's 7 out of 8, so I've got to create a table of size 16. Wow. Give me a space, okay. So 0, 1, 2, 3, 4, 5, 6, and since I'm almost I'm already up to 6, I'm pretty sure that I don't need any bigger table. 7, 8, 9, 10, 11, 12, 13. Let me grab this guy, push him, get him out of the way. That's for the extra credit. Okay. $14 and $15. Now we'll take the existing stuff and rehash them. Put them in this new hash table. So 2 is still 2. 3 is still 3. 11 now is 11. 12 is 12. 21 goes in position 5. 6 is in position 6. And 23 is 16 plus 7 in position 7. So now everything, there is only 1 in each spot. So now let's add in some more. 9 goes in position 9. 1 goes in position 1. Okay. And 5 goes in position 5 after the 21. So, okay. So that gives me all of these, and there are a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of 16, which is less than 3/4. So we never needed to make that any bigger. Now, so that is our final hash table. Now the extra credit was, what's the average search time? So that's the same thing we did before, except I think I'll do this a little faster way. I know 0, 4, 8, 10, and 13, 14, 15 are all zeros. So every 0 mod 16, every 4, right? Empty things, 8, 0, 4, 8, 10 mod 16 are all 0, and 13, by the way, these yellow guys are no longer applicable, so let's unhighlight those. Unhighlight this, don't ignore that this is from, I just copied the previous stuff. Okay, so I'm going to unhighlight these guys. Just ignore that. Boom, boom. Okay, I try to set things up in advance, but I get a few things. There. Nothing's going to be highlighted, is that? 13, 14, 15 are all zeros. 13, 14, 15 are all zeros. And then 16 is 0 mod 16. Then 20 is 4 mod 16. Then 24 is 8 mod 16. Then 26 is 10 mod 16. 29, 30, 31, or 13, 14, 15 mod 16. Okay, 32 goes another 0. 36 is another 4. 40 is another 8 mod 16. 32 plus 16. 42 is 10. 32 plus 10. And 45, 46, 47, and 48 is 0. And those are all the zeros. So those are all the empty. So I filled in the zeros for all of the empty guys from here. Now, the 5 mod 16s are going to be 2, except for 21, which is 1. Okay, so 21 is going to be 1. And then everything else 5 is going to be a 2. So 5, 9, okay. A second, 5, not 9. 16 plus 5 is 21, which is a 1. 21 plus 6 is, okay. 32 plus 5 is 37, which is a 2, right? 48 plus 5 is bigger than 49. So those are the 2s. Everything else is, all these other rows besides the zeros are going to be 1s. So this, that, that's everything else. So I'm going to fill the rest of the table in with 1s. 1. 1. Oops. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. So now I just got to add up all these numbers and divide by 50. So it'll be 1 plus 1 plus 1. I'm not going to add the zeros in this time. 2 plus 1 plus 1. 1 plus 1 plus 1. 1 plus 1 plus 1. Scroll over a little bit. We'll have 1 plus 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 2 plus 1 plus 1 plus 1 plus 1 plus 1. Scroll over again. And plus 1. And that is going to equal this divided by 50 equals 0.62. So the actual number of comparisons you need for this hash table is less than 1 on average. Isn't that cool? And so that's the extra credit for 4. And that's the end of question 1, using a growing hash table with a load factor of 0.76. What is the resulting hash table? And the answer, once again, not the extra credit, but the answer is all of these. So all of these guys is the answer to the question. You guys show all of that. And that's all the work.